Hello viewers, good day to you all. You're welcome to today's class. I remain your pro guide Aisha Bande. The video is sponsored by Proj Connect. Kindly go to the Play Store, search for Proj Connect for you to get started to get exciting and educative videos for undergraduate university students. So we have today in our class we'll be discussing on the topic which is called the set theory. We'll be solving some few calculations under the set theory. But before we begin with the calculations, I would love to explain what to mean by the set theory. That's the definition, also the types of set theory we have, the real life applications of set theory, and we move on to the calculation aspects of the topic. So to begin with the definition, set is defined as a collection of distinct objects. There are examples of set. We can say a set of people, a set of books. So next, let's talk about the notations of that are used in set theory. Sets are usually denoted in uppercase, which we call the capital letters. Example, sets are given in capital letter A, B, C, etc. So sets are not given in small letters, okay, but rather in capital letters. That's very important. Another notation of set is that the elements of a set are written within curly braces. This is what we mean by the curly braces, okay, something of this nature, okay, where we have the elements of a set, let's say one, two, three. So this is what we call the elements of a set. They are written in curly braces, okay, so these are called, these are known by curly braces, okay. So these are the important notations we need to know under the set theory. Let's move on to the types of sets. The first type of set I want to discuss is what we call the finite set, which is called the finite. So the finite set is simply a set that has limited numbers of elements. For example, if you have a set A, is given in an element one, two, three. So this is what we call a finite set, but it has limited number of elements. The second type of set is called the infinite set. The infinite set is a set with an unlimited number of elements. For example, so this is under the finite set, it has unlimited number of what elements. For example, if you have a set B, the set B is giving us one, two, three, then you have like dots, dots, dots. Okay, so this is infinite set. That means the infinite this set B has an infinite set of what of elements. Okay, the third type of set is what we call a subset. Okay, subset, and the subset, this is denoted as this. So this is a symbol for subset. Example, if you have a set A is a subset of B if all the elements in set A are also contained in set B. If set A is a subset of B, this is how we denote it. We note it as subset A is a subset of B, meaning that all the elements in set A are also found in set B. So the first type of set we'll be discussing is known as the universal set. The universal set is denoted with the symbol which is like capital letter U. Okay? Universal set is a set that contains all the objects under consideration given in a set. So the next type of set, the empty set. Another name for empty set is called the null set. Okay? So the empty or the null set is noted with this symbol. When we have this is also called a null set, a set without elements okay within it, okay, so this is a null set. A null set or empty set is a set with no elements, okay. Basically under the set theory, these are some of the few types of sets that we'll be discussing. So let's move on to the next step to discuss the real life applications of set theory. Set theory in real life is used in computer programming, it is used in engineering, it is used in database management. Set theory is used under probability theory as well. These are some of the few applications of set theory in real life. So now let's move on to the calculation aspect of set theory. Under the set theory, there's what we call the Venn diagram. When we are given a mathematical question, which is more like a word problem, when we interpret this word problem, we can interpret the word problem in form of a pictorial representation. And this pictorial representation is what we call the Venn diagram under the set theory. So as we solve examples under this, we shall explain further. Okay?